Good morning, everyone, and welcome. I'm Carrie Burke, your moderator for today's webinar, Create a Unified View of Your Application Security Program. You may send in questions at any time during the presentation via the Q&A chat feature. We will collect these and address them at the end of today's presentation. I would now like to introduce Dan Cornell, a globally recognized application security expert who holds over 15 years of experience architecting, developing, and securing web-based software systems. As Chief Technology Officer and Principal at Denham Group, he leads the technology team to help Fortune 500 companies and government organizations integrate security throughout the development process. Presenting alongside Dan, we have Mike Pittenger. Mike has 30 years of experience in technology and business, more than 25 years of management experience, and 15 years in security. For the past several years, he has consulted independently, helping security companies identify, define, and prioritize to benefit to customers of their technologies, structure solutions appropriately, and bring those offerings to market. At Black Duck, he is responsible for strategic leadership of our security solutions, including product direction and strategic alliances.
Thanks, Carrie. And I wanted to thank everyone who's attending today and thank Mike for coming on to present with us today as well. Excited to have folks here today. We've been doing a series of these presentations of the various partners and technologies that we integrate with ThreadFix, and I think we've got some really interesting things to talk about today, looking at how organizations can use Black Duck Hub and ThreadFix together to have a unified view into their application security program across the various types of software assurance activities they're doing. And there's also some really interesting interactions that you see if you're trying to manage the risk associated with code reuse, both with open source components as well as with internally developed components. For the agenda, Mike will give an overview of Black Duck Hub, talk about how it works and the value that it brings. I'll go through and provide an overview of ThreadFix and how organizations use ThreadFix to manage their application security programs. And then we'll talk together to look at how using Black Duck Hub together with ThreadFix provides organizations with a tremendous amount of value as they try to have a comprehensive application security program where they're managing the risks associated with code reuse. Now I'll turn things over to Mike, and he'll get us started.
Thanks very much, Dan, and it's good to be here. Thanks, everyone, for joining us. I want to take you a little bit through a little bit about Black Duck and our solution and why we wanted to partner with Denham Group, some of the problems we can solve together. So Black Duck has been around for about 14 years. We are a company that sells software that analyzes and identifies open source components in our customers' code. We've been around, as I mentioned, for 16 years. We have almost 300 employees now, a couple thousand customers in 24 countries. So we've been doing this for quite some time. If you look at how our company came about, it was really built around open source, obviously. And if you go back to 2002, open source wasn't often used. In fact, a lot of people would use our application to identify open source so they could get rid of it because they didn't trust the licenses that it was issued under. They didn't trust code that they hadn't written themselves. And we've obviously seen that change dramatically over the past 15 years. Today, it's not uncommon for us to see applications that are 80 or 90% open source. And in fact, we'll go through some of the statistics from our research on this. But even commercial applications are making more use of open source. Now, it's easy to understand why open source has been embraced so highly, and that's really because it provides a lot of required functionality without having to write the code from scratch. So it's lowering development costs while accelerating time to market. If you think of a third of the average commercial application being open source, that's saving the company, if they had to build 2/3 and then it would be another 50% of the development workload to recreate the functionality that they're getting from open source. But it can also have some consequences if you're not carefully managing what you have. So you've probably seen or heard about in the news these vulnerabilities, Heartbleed, shell shock, and so on. And they have something in common. They were all in very popular open source components. They were all, those vulnerabilities were all present in the code base for years, in spite of, hundreds or thousands of security assessments. So Shell Shock had been in Bash for about 25 years, Heartbleed and OpenSSL for about 3 years. And if you think about how many times those components were included in security assessments through static analysis, dynamic analysis, interactive analysis, manual penetration tests, and so on. But in spite of all of that testing, it took a security researcher to go and examine the code to identify that vulnerability manually. Now, what happens when these get into your applications and without your awareness? So we did a little study on that. We have a part of our business that does on-demand audits. So typically, we'll be brought in during an M&A transaction and asked to scan some code on behalf of the acquirer to identify the open source in the code that they're acquiring or the company that they're buying to make sure that they have IP things covered and no terrible security issues. So we went through about 200 or 300 applications this year, and here are some of the highlights from that. So all of the applications we analyzed had open source. On average, the code was comprised of about 35% open source in the average application. 2/3 of those applications had vulnerabilities in the open source. So you think about that. If you're using open source and you're not monitoring it in the commercial code that we've examined, 2/3 of the time you're going to have vulnerabilities in those code. The average application had over 100 components. And this was interesting. It didn't really surprise us, but it certainly surprised our customers. Now, we will ask a customer prior to doing an audit if they have a list of the code, the open source they're using, and in the vast majority of cases they don't. But when they did, on average, they were estimating that they had 40 to 50 components, and they actually had 100. So they were off by a factor, by 100%. On average, there were 22 vulnerabilities in those 105 components. The next statistic is one that really surprised us. So we thought, well, maybe these are vulnerabilities that came about recently and the customer just hadn't fixed them yet, or maybe there were little obscure ones that hadn't done it. The average age of the vulnerabilities in terms of from the difference between the date that vulnerability was publicly disclosed, typically in National Vulnerability Database, and the date that we did our analysis of that application was over 5 years. So these are components that were either added with vulnerabilities directly into the code base or developed vulnerabilities over time but weren't remediated because the customer just wasn't aware of either A, they were using the component, or B, that a vulnerability had been disclosed. So we thought, well, maybe the big well-publicized ones like Heartbleed and Shell Shock and so on were being caught. Over 10% of the applications we tested had the Heartbleed vulnerability in it. Over 10% had Poodle in it. So these were, even the well-known vulnerabilities were not being covered. So we asked, one thing to think about is why aren't these things being found in testing? Because clearly people are using static analysis and dynamic analysis and doing pen tests and so on. And it's because these tools aren't perfect. So static analysis, as you probably know, will take in most cases, the source code, create an intermediate representation of that by mapping out control flow and data flow and calculating variable values and so on, and then running rules against that or running tests against that to identify vulnerability or coding errors like SQL injection, cross-site scripting, and so on, and provide the results right in the source code. Dynamic analysis is a little bit different. It's going to be used much later in the SDLC because you need a fully functional application, you need a staging environment with data behind it, and so on. So typically late in the SDLC, and that's going to be testing the application as a running application, and it may look for inputs and provide fuzz data into those. So look for an input field, looking for a password, and put in a SQL command or put in 1,000 zeros, that type of thing. And in those cases, the results will be shown as a URL with the input that was provided and a trace, and an output of that, but typically not traced to the source. So what's missing from all of this? So what's missing is, nothing really from the standpoint of what the tools are doing. They're doing what they're designed to do, but they're not perfect. So they're able to find common coding errors that could result in security vulnerabilities and report those in the form that they do. So the little Venn diagram to the right is something that we did in the early days. I was one of the founders of Veracode in the early days. We went through all of the common weaknesses as defined by NIST. So that white bubble represents, I think at the time it was about 600 CWEs. And we went through each one of those individually and asked, is it theoretically possible to find this CWE using static analysis, and is it theoretically possible using dynamic analysis, or can you find it with a smart human, a security researcher? And I don't remember the exact numbers, but it was something like, say, 350 you could theoretically find with static analysis, a similar number that you could find with dynamic analysis. Obviously, there was an overlap for things like SQL injection, cross-site scripting, buffer overflows, and so on. But there are a whole bunch of vulnerabilities or weakness types that you couldn't find with these tools, even theoretically. And what's more, each of these tools is going to be a little bit better at different classes of weaknesses, depending on the algorithms they use and so on. But they're not going to be perfect. So take Heartbleed, for an example. Heartbleed is a buffer overflow. So that would fall into the middle of that Venn diagram. It's theoretically possible to find buffer overflow with either of those technologies. But Heartbleed was nuanced enough, complex enough, that the tools just weren't capable of finding it. And that's still true today for static analysis. You could run an old version of OpenSSL through a static engine, and it's not going to show up with the Heartbleed vulnerability because it's still just not capable of finding them. And this becomes a problem. So you look at the number of vulnerabilities that are reported against open source components each year, and you can see in NVD they're between 2,000 and 3,000. The little blue bar of that, the portion of that stack bar, are vulnerabilities that we include from VulnDB. So they're about 20 to 30% more vulnerabilities that Black Duck provides to its customers, and these are just on open source components. The interesting thing around here, and just to try to continue on the fact that while static and dynamic analysis engines are really good, you have to understand what they're best at. So those, about a year ago, I went through these, and there were about 74,000 vulnerabilities in NVD at the time. And full disclosure, I didn't go through each of them individually, but I made an assumption that if I were a tool vendor and my tool had been able to identify a new vulnerability in open source in the wild, or in an application of any type in the wild, I'd want to take credit for that. So I did a search against those 74,000 for common vendor names, IBM, HP, Fortify, WebInspect, AppScan, Veracode, and so on. And of the 74,000, 63 of those CVEs referenced automated tools. 50 of those were for vulnerabilities in the tools themselves, and 13 were for vulnerabilities that could be identified. I can't remember the exact wording, but it was something along the lines with this could be found with a properly configured fuzzer, something along those lines. So not a very good track record with the automated tools at finding new vulnerabilities in open source or in the wild. And this continues to be an issue because we have very little control over how open source enters our applications. So if we're not keeping track of that we're using an open source component, and there are 2,000 to 3,000 vulnerabilities reported against these every year, we're not going to be able to fix that. So open sources we typically think of it as coming into the code base through a developer knowing they need some functionality. They go to SourceForge or GitHub or the project homepage and download it and add it to their component or their application. And that is a pretty common use case, obviously. But it can also come in through commercial components that you use. So we just saw that on average the commercial applications have about 35% open source. If you're outsourcing development, those outsourcers are highly motivated to use open source because of the faster delivery time that and the reduced development costs that it provides. You may be building some internal components for reuse, and those can have open source in them. So you end up with open source in a variety of places, coming into the code base in a variety of ways, and you end up with a mishmash of custom code, commercial code, and open source code. And as vulnerabilities are disclosed, you need to manage those. So we talk about 5 really good practices for managing open source. First, you should have policies around that so that you understand what types of third-party components, including open source, you're going to allow in each application, depending on its criticality. You're going to now make sure that you inventory these so that you have an inventory or a bill of materials of all of the open source you're using, and can assure yourself that it's meeting those policies. Once you have that bill of material, you can map the components, map information about the components to that. So we provide this to our customers by mapping it from vulnerability information, license information, and operational risk information. If there are any risks associated with those, for instance, for license risk, if you're using an open source component that's been licensed under GPL and you're distributing that product, that could present some IP risk. If there are known vulnerabilities in that component, that can present license risk. Or if it's, Sam and Dave are 2 guys in their garage working on an open source component and you're embedding that in a device, you may want to use a component that has a better supported community that would present operational risk. So if you're doing this throughout your SDLC, what you can assure yourself is that when you ship that code or release that code, it's free from vulnerabilities and risks associated with the open source that makes up whatever portion of your app that makes. That's only part of it, because security is so ephemeral with software. It's going to change as new vulnerabilities are disclosed. So you need to continue to monitor that threat space over time so that as new vulnerabilities are disclosed, you have an alert into your system so that you can do an incident response in a timely manner and in a rational manner. So this is an example of what the output from Black Duck would look like. So when you run a scan, the output of that is going to be we call it a bill of materials. You can think of it as an inventory of all of the open source that's being used, and along with the security risk, license risk, and operational risk associated with it. We'll also provide specific information on vulnerabilities from a variety of sources. And this is all very good, obviously, but now this needs to, we understand that this is something that is adjacent to and complementary to the static analysis that you do or the dynamic analysis that you do, threat modeling, penetration testing, and so on. But the goal of many organizations is to get this into a single place for triage, for prioritization, and for remediation, and that's where ThreadFix comes in. So our key takeaways from this is open source is here to stay. The benefits far outweigh the risks. It's adding a lot of value to the organization, reducing costs and making it easier to get to market with products, particularly in an agile environment. This is important. Open source isn't covered by traditional tools, so we typically run alongside static analysis or dynamic analysis. Those would be typically later in the organization because they're going to be a little bit heavier or a little bit more time-consuming. Black Duck is typically integrated right into the build server in a traditional CI or a CI/CD Agile DevOps type environment. So the analysis is very quick. You get results very quickly, so you can address those whether you're doing that on a daily build or actually with every commit. And as you look at the changes that are happening in the environment with DevOps, with containers, and so on, you need to be prepared to adopt new methodologies. So integrating security into the Agile group, looking at open source security as something that's distinct from the type of security, application security issues that static and dynamic analysis deliver. And with that, I'll turn it back over to Dan.
Thanks, Mike. There we go. Take back over here. And so I think Mike makes an excellent point, and this is something that we see even in organizations that aspire to have very tight control over the use of open source components and open source code. In our working with these organizations, we find that the open source finds a way to creep in. There's too many incentives for developers to want to use it, and they will find ways around that. And I think what the folks at Black Duck are doing is very interesting as organizations start to focus more on the software supply chain to look at all of the things that come together to get their software. Also, with the unveiling in 2013 of the 2013 version of the OWASP Top 10, this is now a concern in the OWASP Top 10 and a concern for a lot of organizations subject to PCI, is to make sure that they don't have risk and vulnerabilities introduced into the software because of their components. So now we'll turn and talk about ThreadFix. And just to provide a little bit of an overview of ThreadFix, ThreadFix is a software vulnerability remediation resolution platform that lets you create a consolidated view of your portfolio of applications and all the vulnerabilities you identify through various testing activities. It lets you prioritize the decisions that you're going to make about remediation based on the risk that you're exposed to. And finally, it allows organizations to translate vulnerabilities into the tools that developers are already using in order to get those developers to actually fix those vulnerabilities. And our goals here are to help organizations reduce risk by making smart decisions and to save time. We want to take care of a lot of the data management and free up the application security team to work on higher value tasks. So if you look at what ThreadFix does, it allows you to ingest the results of all of the different types of testing that you're doing. As Mike mentioned, the traditional view of an application security program, very focused on static analysis, very focused on dynamic analysis. But now organizations are also starting to look to new types of analysis to identify weaknesses and vulnerabilities that they maybe were missing before. Interactive application security testing be a great example, as well as the managing the life cycle of the components that are used for the software. So ThreadFix allows you to pull all of those results across the different testing activities into a central repository. But it also lets you keep track of the results of manual testing activities. So if you're doing manual code reviews, if you're doing application penetration testing, you can also import those results into ThreadFix to live alongside the other results. And similarly, if you have third parties that are doing reviews of your software, you can load the results of those in as well. And so what that gives you is one central place where you have tracked the results of all of your software testing or your security testing and software assurance activities. From there, then you can start to make decisions and to push this data out so that it can be best consumed by their stakeholders. This lets you do reporting not based on the stovepipes of things you are doing in your program, but across all of the activities in your program as a whole. It also lets you translate these vulnerabilities that security teams care about into software defects, because those are what developers care about. And so if you can get these vulnerabilities turned into software defects, we found that helps developers to actually resolve these vulnerabilities and resolve them much faster. You can also push out to other developer tools like IDEs, as well as report up to GRC tools. And this allows you to take the results of your application security program and to make those available in the proper tools in the proper form to other stakeholders. So let's look at creating a consolidated view of your applications and your vulnerabilities. First, in ThreadFix, you can lay out your application portfolio. So you can lay out the different teams you have spread across your organization that are developing software. And you can lay out the applications that each team is responsible for and rank these by the criticality and the risk that you're exposed to because of them. Based on this, then you can start loading in the results of all of the different testing activities. As I mentioned before, if you're doing dynamic scanning, if you're doing static analysis, if you're doing IaaS testing, if you're doing component lifecycle management testing, you can load the results of all of those along with all the manual activities. All of these get loaded into ThreadFix. And what ThreadFix does is it normalizes and dedupes and consolidates these vulnerabilities so that you have one single view into the vulnerabilities associated with an application. One of the things that we can do, and this is technology that we've developed with support from the U.S. Department of Homeland Security Science and Technology Directed Cybersecurity Division, which is a very long acronym. But one of the technologies we've developed is called hybrid analysis mapping, and what that allows us to do is to correlate between vulnerabilities found by dynamic security testing, essentially fuzzing web applications. We can correlate those with the vulnerabilities that are identified by static application security testing, static analysis, or source code analysis. And so this allows you to get a very good view into the veracity of the findings that are coming out of these testing tools, because you can see where these tools overlap. To touch back on another point that Mike made, there are certain things that static tools are good at finding, certain things that dynamic tools are good at finding. And the hybrid analysis mapping lets you stitch those together so that you can look and see, here's, these aren't two independent findings that need to be triaged and handled separately. This is one vulnerability, and we have two pieces of information about it. So we can see here's the request that goes into the application, the data or control flow within the application, and here's the response that got sent back. So as you look at the task of managing this data, identifying false positives, and prioritizing vulnerabilities, by having all this data in one place and correlated, that makes the security analyst job much easier. So once you have the results of these different testing activities, you have to make some decisions. The reality is you're never going to fix all the vulnerabilities that you identify in the code. I wish I had a different answer for you, but that's just the simple reality. And so as a security analyst, you're going to have a budget or a set of resources. You need to make good decisions on how you deploy those resources so that you can address the maximum amount of risk with the level of resources that you have available. So with ThreadFix, this allows you to go in and slice and dice this vulnerability data. You know the criticality of the applications, and you can go in and identify which of the vulnerabilities that I think are the most serious. You may be looking and saying, well, this application manages a lot of sensitive data. We can't have any SQL injection vulnerabilities. Well, that may be the decision that you make. However it is, ThreadFix gives you the tools to slice and dice down into that data so that you can make good decisions about how you shepherd your resources in order to, again, address the maximum amount of risk for the available resources that you have. You can also look across your program. One of the great things about having all of these testing activities in one central location is it gives you a view across your entire program. You're not just going to be able to look and see, well, what did we do with static analysis? What have we done with dynamic analysis? We're doing a pilot with this new vendor for some new technology. ThreadFix lets you look across your entire program and to dive in as needed. And this puts security managers in a position where they can take a much more quantitative view of their application security program. That's one of the challenges that we see working with organizations as they build and evolve their application security programs. Organizations, by and large, they've figured out how to spend on things like antivirus, how to spend on things like firewalls, but application security is a much less mature discipline. And so organizations are still trying to figure out, how do we budget for this? What are the reasonable expectations? By having all the results of your testing activities in one central place, you can start to look and see, what do our remediation rates look like? How many vulnerabilities are we fixing? How long does it take us to fix them? And you can start to compare yourself with external industry data sources. For example, the State of Software Security report from the folks at Veracode, or the similar document that's published by Whitehead. So you can start to look and see, how do we perform versus other people that are similar to us in our industry? And you can use that as an entry to have a more grown-up set of conversations with management. Instead of going to management and saying cross-site scripting is scary, you can go to management and say, other organizations like us are fixing more vulnerabilities and they're fixing them faster. I need more management support, more resources, or we risk falling out of step with our peers. And this also lets you run experiments to look at how certain technologies perform against other technologies. It lets you prioritize resources. For example, if you know that a certain team is bad or has a high incidence rate of certain vulnerabilities, you may bring in a trainer to work with those folks. Again, by having all of this data in one central place and being able to slice and dice that, it puts you in a situation where you can have a much more sophisticated and grown-up set of conversations with management. And that helps you to justify budget and to set yourself up for success in the future. Finally, ThreadFix allows you to translate these vulnerabilities. Again, vulnerabilities are things that security teams care about. It lets you translate those into the tools and the processes that development teams are using. And this, whether it's done through ThreadFix or through some other means, this is probably the most critical thing that we've seen that differentiates between application security programs that are really challenged and struggle to make progress and the ones that start to make headway. And that is taking these vulnerabilities and putting them into the tools that the development teams are using. There's a perception, I think, in a lot of cases that developers don't care about security, but I don't agree with that. Developers do care about security, but they also have to care about new features that a hotshot VP promised to an important customer. And they do have to care about non-security related bugs that are impacting the customer experience. And they also have to care about performance issues that aren't security related. And so security is just one of a number of things that development teams have to care about. And by recognizing that as an application security team, that brings you more credibility. And so instead of having security be something special where you mail over a PDF, that the development team has to decipher and deal with. Instead, if you can package up these vulnerabilities via ThreadFix and put them into the tools that the developers are already using, you can take advantage of the large investment that these development teams have made in the tools, bug trackers like Jira, Bugzilla, and so on, but also in the process that they've used to allocate and do work. So if they're using Scrum, if they're doing some other sort of Agile, your security backlog turns into their technical backlog that gets assigned along with new features and so on and so forth. This also allows you, via ThreadFix, to monitor the progress of the development teams as they say they've addressed these vulnerabilities. So instead of having to chase these teams around with a clipboard, you can see as they go and mark defects as being addressed, you can queue up retests to identify were these vulnerabilities successfully addressed by the development team, or do I need to reach out to them and provide them with some mentoring and some advice? This makes for a much better set of interactions between security teams and development teams and puts you in a position to act as a consultant, as an influencer and a support, as opposed to an adversary. ThreadFix also has what I think is some really interesting technology that we developed coming out of our work with a number of organizations. And that technology we call HotSpot. And what HotSpot does is it looks at all the results of static analysis testing and IaaS testing that have been done and imported into ThreadFix. And in addition to ThreadFix allowing you to look within an application for for vulnerabilities that have been identified, the HotSpot technology looks across all of the static analysis results, and it identifies situations where it appears that you have internal code that is being developed and reused across applications and teams. And this allows you to have insight into situations where there may be higher value vulnerabilities to fix in one area than others. This came out of a lot of consulting work that we've done across a number of organizations where we would help an organization test an application, we would go work with the development teams and advise them on remediation. And for certain vulnerabilities, the development teams would say, hey, I don't own that code. I can't fix that code. I get that from another group, and they own that code. So if you want that vulnerability fixed, you've got to find those folks. This happened over and over again, and that's why we built this technology to help automatically identify these situations where code is being shared across teams and applications, and that code contains vulnerabilities. So this allows you to identify vulnerabilities that may be higher value to fix. If I can go to the source team, get them to fix a vulnerability, and then push that component downstream to the other 20 applications that are using it, I've fixed one vulnerability, but I've addressed that vulnerability in the 20 downstream applications. And so that identifies for us points where we may have some leverage, where fixing one vulnerability doesn't just fix one vulnerability that gets exposed, but fixing one vulnerability in code and pushing that code out to the consumers fixes multiple vulnerabilities. And so this is doing something very similar to what Black Duck Hub is doing focus on open source components and known vulnerabilities in these open source components, but this is allowing you to identify that internal code reuse and that reuse of components that similarly is going to expose your organization to risk, but where you otherwise wouldn't know that. And this is a great way in a lot of environments to identify, sometimes formal code reuse relationships, sometimes informal code reuse relationships. But as security taking these data feeds in from across the enterprise, this lets you know more about how code is migrating across your organization so that you can start to better target your efforts as a security team to work with the teams where you're going to have the greatest impact. All right, now we'd like to open things up for questions. As Carrie said, please use the Q&A feature and we will get some questions answered. All right. Okay, we've got a question here. Are the number of vulnerabilities increasing? Mike, do you want to maybe weigh in on that?
Yeah, sure. So I mean, we show in our slides that there are typically 2,000 to 3,000 vulnerabilities in open source every year. If you look at NVD, last year the number of vulnerabilities in commercial components actually, or commercial software actually outstripped those in open source. And I think that's significant because open source is, it's kind of the playground for researchers, and it's simpler to find vulnerabilities there than it is in black box testing commercial applications. In terms of the numbers going up, there are a couple of things there. I think we're finding more because we have more people who are qualified and capable of finding them. If you go back 10 years, there weren't a lot of people around who were capable of doing manual code reviews to identify security issues, and we're printing those people at a higher rate now with programs out of universities and just general awareness around application security. So I don't think there are certainly a lot being produced every year. We don't think that it's increasing at a high rate, relative to the number of open source components that we track. Yeah, there are more, but I think in general, but I think that's because there are more people capable of finding them as opposed to it being less secure software being written.
Great point, Mike. And to speak, looking at internal enterprises, are the number of vulnerabilities increasing? Not looking specifically at open source, but at these internally developed line of business applications. I think that the number of vulnerabilities identified are increasing, but as Mike said, I think that's because organizations are doing more testing across their application portfolios, and that can be discouraging in a lot of cases for organizations where if you look at just the raw vulnerability counts that have been identified, they just seem to go up and up. But for organizations that have more mature or starting to mature their application security programs, we do see that the introduction rate of vulnerabilities does start to decrease. And as organizations start to remediate, then again, with some focused efforts, organizations can reduce those introduction rates and start to remediate vulnerabilities and get this problem under control. It's a challenge for organizations, especially where they have a lot of software. But if you look at combining training as well as testing as well as a focus on remediation, that puts organizations in a situation where they can get their arms wrapped around the scope of the problem. And so they can, again, get to a situation where their risk exposure is much better managed so that they can decrease it over time. Next question. What's the benefit of the ThreadFix Black Duck Hub integration? Again, Mike, do you want to maybe talk about that from y'all's standpoint?
Yeah, I'm happy to, Dan. What is attractive to us is that a lot of organizations use a variety of tools, and we would not recommend necessarily that Black Duck be your only security solution. Just as the commercial tools don't help with the open source identification isn't helping with finding common coding errors that result in security issues in the code you write. So you need a variety of tools, and you may even use a variety of tools within a class of tools. So you may use one static engine for C and C++ and another for your mobile apps or for Java apps or something like that. You may have individual security testers who are using different tools, and if you're doing a third-party pen test, they may have an entirely separate set of tools. So our goal isn't necessarily to have our customers bound to our UI, that we can provide a lot of information in it. Many times they need some place to triage all of their vulnerabilities at the same time, and we saw ThreadFix as a great fit for this. That, I guess, that in few words, that's what was attractive to us about this.
Excellent. And from the ThreadFix side, as we talked about, I think for a lot of people in the industry, and this is starting to change, but for a lot of people in the application security space, when they think of testing, they think only of automated static or automated dynamic. But as we've discussed today and seen from talking with Mike, there are tremendous risks associated with the management of components and how open source gets used in software. And so for ThreadFix, it's incredibly valuable to be able to pull in the results of this open source analysis and this component lifecycle management analysis, and to see that alongside static testing, dynamic testing, as well as all the manual testing activities as well. What we want to be able to do is to present a complete picture of the risk you're exposed to so that security analysts can make the best decision possible about what activities they need to undertake in order to reduce the most risk. And being able to pull data from Black Duck Hub provides a tremendous data feed about these types of risks. And so it's, again, we're really excited about this integration. Next question, is open source more or less secure? This is somebody's trying to start fights.
Yeah.
You have some thoughts on that, Mike?
Yeah. I mean, we get asked this from time to time, and it, as I think you were alluding to, it's kind of a religious argument. We're obviously big fans of the open source community, and I guess my feeling on it is it almost doesn't matter. It's software. Software's going to have bugs. So it's not that it's more secure or frankly less secure than commercial code, but there are characteristics of open source that make it particularly attractive to an attacker. So, if you think about it, it's ubiquitous. So when there's a vulnerability in OpenSSL or in WordPress or Linux or whatever, you've got a pretty target-rich environment there if you're a bad guy. We go to the trouble of publishing the vulnerabilities, and often we'll publish the vulnerability with an exploit to prove the vulnerability, and we post that up in NVD or VulnDB or someplace like that. The bad guys have access to the source code, so they can take that vulnerability and take that exploit and modify it. They can test it against an IDS. If they're still confused, there's probably a YouTube video someplace that will show them how to do it. But the biggest thing, I would argue, is the support model. So if Dan and I were going to make an application and we wanted to pull information out of a database and display it in a pie chart, we could buy a commercial component to do that. And if we did, we'd have an SLA with that vendor, and they'd be obligated to take our phone calls and answer stupid questions, and if there was an update, they'd push that to us. And if there was a security issue, they'd push us a patch and notify us. And open source isn't like that, right? So if we go and download a component, open source component to do that, we've elected to include that in our code and abide by the license terms. But now it's up to us to monitor that. And if there's an update, nobody's going to push anything to us. If there's a security issue, we've got to educate ourselves to that and make an election as to whether or not to download or pull in a new component. So it's a push versus a pull model, and that's pretty easily addressed if you're using a single component and you're diligent about it. But as we saw in the average commercial application, there's 100 open source components and 2,000 or 3,000 vulnerabilities a year. So that pretty quickly becomes a complicated process. And if you multiply that by 10 applications or 100 applications, or some of the banks we work with, thousands of applications, it's a real issue. So they're concerned about open source vulnerabilities because they're so simple for an adversary to try, and they can use them against you specifically, or they can do a non-targeted attack and just point an exploit out at a few thousand IP addresses to see who's vulnerable. So I guess just to summarize that, I'll defer on the question of whether it's more or less secure than commercial software, but we'll say that there are aspects of open source that do make it an attractive target.
Great point. And again, we do security testing for a lot of commercial software and find vulnerabilities. We've been contracted to do security testing for open source software. We found vulnerabilities. But I think Mike makes a great point that at the end of the day, the answer to that question is somewhat moot, because overwhelmingly your software development teams are going to be using open source, and therefore you need to deal with the security associated with that. It's just it's kind of a pragmatic decision that you need to make as a security team. I remember a conversation that I had with one of our large banking customers talking about mobile security, and their security analyst position was we should only release our app on BlackBerry because of the way that they handle the encryption keys and whatnot. That was the only platform that was appropriately secure. So my question was, what percentage of your users are on BlackBerry? And the answer was 10%. Everyone else was on iOS and Android. And so my answer was, it doesn't matter which platform is more secure. What matters is that you're forced to, if you want to serve your customers, you have to provide access to iOS and Android. Flipping that around, looking at development teams, you can tell development teams that you're scared about open source and you don't want them to use open source, but the economic incentives for those teams to use open source are likely to trump your attempts at risk management. And so, again, that's why it's great to have a system like Black Duck Hub to identify those risks so that you can make informed decisions about, do we need to upgrade, do we need to use another component, do we need to fork it and make changes of our own? That gives you the information, and by being able to look at those risks alongside the other risks you're exposed to, that hopefully puts you in a position where you can be a good shepherd of the limited remediation resources that you're likely to have. Next question is, does ThreadFix also ingest, correlate, and report on infrastructure vulnerability scan data? Great question. We have support right now. The answer is right now, kind of. In the future, probably better. Right now, we can ingest the results out of the box. We can ingest the results from Nessus scans and associate those with a specific application. There are also a couple of ThreadFix deployments where we've helped to customize and extend to allow for additional infrastructure and network testing vulnerabilities. Going forward, that's something that we're going to be expanding the ability to manage those as well. But right now, most organizations that are have the largest deployments of ThreadFix are the ones that are running application security programs that are reasonably sophisticated, that are trying to make more sophisticated. From a tool support at the current time, very broad and deep support for static analysis, dynamic analysis, IAST, as well as component lifecycle management, with some ability and support for the infrastructure level vulnerabilities. Next question, does ThreadFix HotSpot detect vulnerable open source components on its own? No, just to clarify, the analysis of the open source components in the scenario that we've described here, the analysis of the open source components is being done by Black Duck Hub, and then ThreadFix pulls that data in to live alongside in ThreadFix all the static analysis, dynamic analysis, manual security testing, and so on and so forth. And so the ThreadFix HotSpot technology focuses, does analysis of, or looks at the static analysis results that have been loaded in to ThreadFix, and so it's looking at the code that's developed in-house and subject to the static analysis, and trying to identify situations where multiple applications share chunks of the same code and where those chunks of code have vulnerabilities in them. And so it's, again, kind of looking at open source or third-party stuff that is where Black Duck is identifying those risks. For internally developed code, that's what the ThreadFix HotSpot technology does. Excellent. Any other questions out there? Well, good. Well, I want to thank everyone who took the time to log on today and sit with us for a little while and talk about ThreadFix working together with Black Duck Hub. I want to thank Mike for coming on today and talking about the great work that they're doing. We'll be making the recording as well as the slides available here shortly. Those will probably be up early next week. And again, just want to thank everyone for coming out today, and I hope you all have a great rest of the day. Mike, do you have anything in closing?
No, but I do appreciate everybody logging into this, Dan, and as always, nice to chat with you.
Perfect. Well, thank you all very much, and everybody take care.